Very good morning, children. Welcome you all to the science session. We are in our chapter 10, Combustion and Flame. That's the title of the lesson. And in that we have learnt about combustion process and combustible and non-combustible substances. Then we learnt about the three types of combustion. After that, ignition temperature, that is requirements for the combustion. Then after that we have learnt how to control fire, yes, and inflammable substances. So in today's class, the last part of the lesson we are touching after learning the structure of flame. Now the last part of the lesson is that is the concept number 10.6, and in that we are going to learn about the fuel. Yes, ideal fuel or fuel efficiency, about all those things we are going to learn. Got it? So we are moving with this. There is the introduction part, already we finished. Now before going to the fuel, we will just once again go to the fire, because one small video is there. Here combustion process is taking place. Here heat energy is liberated. For domestic and industrial purposes, we are using wood, charcoal, petrol, kerosene, etc. We are getting heat and light. So these substances, whichever we are using for the heat liberation or energy liberation, that's called as combustible substances. In the video you have seen wood was burning, coal was burning, correct? What's the purpose of burning all these things? To get heat and light. Yes. Now, why do we burn wood? We burn wood because it's a fuel. What's the meaning of fuel now? The substance which is ready to burn, correct? The heat and light produced while burning wood is used to keep warm, cook, to help us to see, burn things. Yeah. So, substances that undergo combustion and provide heat energy for various industrial and domestic purposes are known as fuel. Now here two words are the industrial. Industrial means in industries, to boil, to melt. Okay. So during that time we are using the fuel. So there we can't use the firewood, because the heat generated in a firewood will be not sufficient. Okay. So there we are using some other types of fuels like coal. Yeah. Now domestic purposes, what we are doing, we are depending upon the LPG, natural gas, or firewood, kerosene. Yes. Now altogether everything is known as a fuel which is undergoing combustion process. Now we will learn more about this. Now fuel can be of three types. It may be solid, liquid, or gas. For example, solid, wood; liquid, petrol; gas, natural gas. Now all these solid, liquid, or gas, are they same? Do you think that? Yes, let us find out. Olden days, we were depending upon the traditional stove, and at present, gas stoves are the electric stoves are they, correct? So now here in the traditional stove, we were cooking the food, correct? Do you know what was the disadvantages? The vessels, lower part, that is below the vessel, the black color used to come while using traditional stove, correct? But in a gas stove that problem is not there. Okay. Which you prefer at present? We prefer to use gas stove instead of traditional stove. Yeah. Traditional stoves use wood or coal as fuel that are not very expensive. However, they release a lot of smoke on burning and are not fuel efficient. Yeah. So here That's why when they will release lot of smoke, they will create blackish color around the vessel. Yeah, and cleaning the vessel also very biggest task. But gas stoves use LPG as fuel, which are expensive. However, they do not release a lot of smoke on burning and are fuel efficient. Yeah. So here one new word is there, fuel efficient and not fuel efficient. About that we will learn little bit more later. Now, all fuels are different. The fuels used differ based on price, that is the cost, availability, efficiency and environmental impact, effect on the environment. Now, I told a new word, fuel efficiency. So, about that we are going to learn more. Now, in this fuel efficiency, when we are learning, suppose you were asked to boil a given quantity of water using cow dung, coal and LPG as fuel, which fuel would you prefer? You may take the help of your parents to decide this. Decided? Okay, next question. Do these three fuels produce the same amount of heat? Do you think so? Cow dung, coal and LPG. Are they same? No. The amount of heat energy produced on complete combustion of 1 kg of fuel is called its calorific value. The calorific value of a fuel is expressed in unit called kilojoule per kg, that is kJ by kg. Calorific values of some fuels are given. Okay, now the thing is, what kind of fuel is more efficient? One with low calorific value or one with high calorific value? So once again we will go back to see what is calorific value. The amount of heat produced on complete combustion of 1 kg of fuel is called calorific value. Okay, we will go further. A fuel is considered efficient when a lesser amount produces more heat. Fuel should be lesser, but the heat should be more. Then it is called efficient, good, best. Okay. So, fuels with a higher calorific value are more efficient, means they are the best. Which one? With a higher calorific value. So, calorific value is directly depending upon the heat energy produced. Okay. So, if the calorific value is higher, then that fuel is called as the best. For example, LPG. LPG is having higher calorific value than the coal and wood. That's why here in these three examples which I gave, cow dung, coal and LPG, selecting LPG as a fuel is the best thing, because it's having higher calorific value and that's why it produces more heat and fuel used that will be very, very less. Look at the table on the next slide and observe the fuels that are more efficient than the others. Now, here calorific value is given, children. First we will go through each and everything, then after that we will start to compare. Okay, cow dung cake. So, its calorific value is 6,000 to 8,000. Wood 17,000 to 22,000. Coal 25,000 to 33,000. Petrol 45,000. Methane 50,000. LPG 55,000. Biogas 35,000 to 40,000. Hydrogen 1,50,000. Now, shall we start to compare? Yes. Now, cow dung cake, least calorific value, means it's not a good fuel. Yes. Then wood 17,000 to 22,000, coal 25,000 to 33,000. So out of these three, cow dung cake, wood and coal, which is the best one? Surely coal, correct. Okay, now we'll go further. Petrol 45, methane 50, LPG 55. Which is the better? Which is the best? LPG is the best. Okay, now here when you compare LPG and biogas, once again LPG stands in the leading point. Okay, now hydrogen. Hydrogen is the topmost fuel which is having highest calorific value. That's why it is the best fuel. Yes. Now here one activity is given, just one problem. We are going to understand the problem here. Sadhana's grandmother would use 5 kg of firewood every day to cook food. The heat produced from 5 kg of wood was 1,00,000 kilojoule. Can you calculate the calorific value of firewood? So she is using 5 kg of firewood every day and it produces 1,00,000 kilojoule of heat. Now we are going to find out the calorific value of firewood. Now total heat produced, that is 1,00,000 kilojoule, amount of wood 5 kg. So calorific value of wood is total heat by amount of wood. So 1,00,000 by 5 kg, so it is equal to 20,000 kilojoule per kg. So what's the calorific value there? 20,000 kilojoule per kg. Sadhana's father later started using liquefied petroleum gas, that is LPG, to cook and needed only 2 kg of LPG to produce 1,00,000 kilojoule of heat. Can you calculate the calorific value of LPG? Once again same process. Yes, we are going to divide the heat produced by amount of fuel. So it will be total heat produced 1,00,000 kilojoule, amount of LPG 2 kg. So calorific value, total heat produced by amount of food. So 1,00,000 kilojoule by 2 kg, it's equal to 50,000 kilojoule per kg. So that time we got 20,000 and now we are, with the help of LPG, we are getting 50,000. So where the calorific value is more? Yes, in LPG calorific value is more. That's why it is, it is the best fuel. Now Sadhana wondered which fuel is more efficient, wood or LPG. Can you tell which fuel is more efficient? I think you understood. Yeah, which one? LPG is the best one. Why? The calorific value of wood 20,000 kilojoule per kg. The calorific value of LPG 50,000 kilojoule per kg. Since the calorific value of LPG is higher than that of wood, LPG is more efficient. Different types of fuels available. Now we will see the different types of fuels and the purposes of using them. So first one, cooking. For cooking we are using cow dung, cake, LPG along with the firewood, kerosene, all that. So here two things we have taken, cow dung cake and LPG, because lots of difference is there, that's why. So first one, cost, price, that is cow dung cake, it's low, very cheap, and LPG high. Availability, cow dung cake easily available, LPG not easily available, it's a limited resource, that's why we have to use in a limited quantity. Then fuel efficiency, that is calorific value, means heat generated, okay, per kg. So heat generated per kg, that is in a cow dung cake, that is very low heat generated, and in case of LPG it is very high. And environmental impact, what's the effect on environment? Smoke is released in a cow dung cake, in LPG no smoke. Yeah. Now here second purpose, to generate electricity. generate electricity. Here two things are given as a fuel, one is methane and one more is coal. Yeah, so price, methane moderate, coal very low. Then availability, methane not easily available, coal easily available. Fuel efficiency, that is calorific value, methane moderate, at the same time coal low calorific value, means heat generated will be low. And environmental impact, methane no smoke, coal smoke is produced. So when you compare to coal, methane is okay, eco-friendly, but coal is releasing smoke. Okay, next third one is for vehicles. Here two things we are comparing, CNG and compressed natural gas and diesel. So price, compressed natural gas it is high and diesel moderate, availability not easily available, diesel easily available. Then calorific value or fuel efficiency, that is moderate in CNG, diesel also moderate. Environmental impact no smoke, and under diesel smoke is released. So in case of eco-friendly, CNG is more eco-friendly than diesel. So these are the three types of purposes we saw, and we have taken two fuels for each, and we compared that and we came to know that the price, availability, fuel efficiency and environmental impact. Yes, now so which one we have to consider it as an ideal fuel? There is no fuel that meets all requirements and can be considered an ideal fuel. While deciding which fuel to use, we should choose a fuel that meets most of our requirements. Yeah, that is high calorific value they should give, then easily it should be available, it should be cheaper, then is less harmful for us and the environment, it should be eco-friendly. That means they should not harm the environment. So the ideal fuel must meet all the requirements, along with that it must be eco-friendly. So do fuels that have a high calorific value also have a negative impact on the environment? We have checked some of the fuels having high calorific value and we are getting more heat, correct? Do they serve as eco-friendly? Now we will come to the point. The increasing fuel consumption has harmful effects on the environment. Carbon fuels like wood, coal, petroleum release unburnt carbon particles. Now these fine particles are dangerous pollutants causing respiratory diseases such as asthma. Now these particles are inhaled by the human being and that causes respiratory problems. Incomplete combustion of these fuels gives carbon monoxide gas. It is poisonous gas. Now we have hemoglobin pigment in our body. Actually hemoglobin acts as an oxygen carrier, but in presence of carbon monoxide, hemoglobin can't take the oxygen, it will take the carbon monoxide because it has more attraction towards the carbon monoxide. So what happens, carbon monoxide when it is inhaled, it becomes poisonous there. So it can kill persons sleeping in the room which is closed and their coal is burnt. Combustion of most fuels releases carbon dioxide in the environment. So increased concentration of carbon dioxide in the air is believed to cause global warming. Now global warming phenomenon already you learnt, that is increased concentration of carbon dioxide in the air increases the temperature of the environment, and due to this what happens, the polar glaciers will start to melt, which leads to rise in the sea level causing floods in the coastal areas. Low lying coastal areas may even be permanently submerged underwater. Then burning of coal and diesel releases sulfur dioxide gas. It is one of the reasons for the acid rain. It is extremely suffocating and corrosive gas Moreover, petrol engines give off gaseous oxides of nitrogen, oxides of sulfur, and these oxides of sulfur and nitrogen gets dissolved in the rainwater and it forms the acid rain. And when this acid rain falls on the land, it will spoil the soil fertility, it will spoil the crops, it will spoil the buildings, and it also poisonous, or it is also harmful for the environment. The use of diesel and petrol in automobiles is replaced by CNG, that is compressed natural gas, because CNG produces the harmful products in very small amount. CNG is a cleaner fuel. So this climate changes, what you can see at present, that is also one of the effect of this burning of these fuels. The earth's temperature has been rising due to the excessive use of fossil fuels. This is causing changes in weather conditions like intense heat waves, melting of ice caps and droughts, affecting both animal as well as plant life. When such changes take place over a long period of time, it is called climate change. So last important points of today's part. Once again we will just check. An ideal fuel is cheap, readily available, readily combustible and easy to transport. It has a high calorific value. It does not produce gases or residues that pollute the environment. Fuels differ in their efficiency and cost. Fuel efficiency is expressed in terms of its calorific value, which is expressed in units of kilojoule per kg. Unburnt carbon particles in air are dangerous pollutants causing respiratory problems. Incomplete combustion of a fuel gives poisonous carbon monoxide gas. Increased percentage of carbon dioxide in air has been linked to global warming. Oxides of sulfur and nitrogen produced by the burning of coal, diesel and petrol cause acid rain, which is harmful for crops, buildings and soil. Children, already we finished this lesson, Combustion and Flame, chapter 6, and we divided the whole session, that is this lesson, into 3 sessions. So now what I'll do, before winding up this session, I just want to give the connectivity from the beginning till now. Just once go through so that it will be easy for you. Reading the textbook, it's compulsory, children. Read the textbook and go through the notes, whatever given. So you can make out all these points. So once I'll touch all these points so that you can recall whatever you learnt in this lesson. Okay. So first we learnt the meaning of combustion. The process of burning, it's a chemical process. Okay. A chemical process of burning substance in the presence of air. Yes, and producing heat and light. Then the substances which burn in air are called combustible, and if they are not burning, they are called non-combustible. Requirements for the combustion, that is oxygen is essential for combustion. Then during the process of combustion, heat and light are given out. Then ignition temperature is needed. Ignition temperature is the lowest temperature at which a combustible substance catches fire. It differs for different fuels. Types of combustion. So types of combustion are three: rapid combustion, spontaneous combustion, explosion. After that we have learnt about flame. The structure of flame, that is important, children, for the exam pointer. Flame, it's a zone or burning vapor. The substance which vaporizes during burning gives flame. Example, kerosene oil and molten wax. So their important word is the substance which vaporize. Okay, so candle wax, it's vaporizing, so it is creating the flame. Kerosene oil, it is vaporizing, so it is creating the flame. But coal is not vaporizing, that's why it is not creating the flame, remember. Okay, next. Inflammable substances have very low ignition temperature, means fast they will catch fire. Okay, so those are called inflammable substances. Fire can be controlled by removing one or more requirements essential for producing fire. Okay, so there water is commonly used for control fires. Water cannot be used to control fires involving electrical equipments or oils. You have seen all those instances, and if you use, what happens, that also you have learned. Then there are three different zones of a flame, that is dark zone, luminous zone and non-luminous zone. Yellow color and blue color. Blue color is non-luminous and yellow color is luminous. Higher heat in the non-luminous, low heat in a luminous. Then fuel is any material that is burned to obtain energy that can be used to heat or move another object. So fuel, about that, combustible substances are called fuel. A good fuel must be ready available, be cheap, burn easily at moderate rate, then produce large amount of heat, then not leave behind any undesirable substances. Fuels differ in their efficiency and cost. Some are cheap, some are costly. Some will give more heat, some will give less heat when compared with the kg. So fuel efficiency is expressed in terms of its calorific value, which is expressed in units of kilojoule per kg. This is very important. Fuel efficiency, that is expressed in the unit kilojoule per kg. Then types of fuels: solid, combustible substances which are solid at room temperature, that is coal, coke, wood, charcoal, etc. Liquid fuels, volatile liquids which produce combustible vapor. Volatile means vaporizable, which can turn into vapor, that is called volatile. Example: petrol, kerosene, alcohol, diesel, etc. Then gaseous fuel, combustible gases or mixture of combustible gases. Example: natural gas, LPG, biogas, coal gas, etc. Now here compressed natural gas is there. Now in that main components, it's methane. Compressed natural gas main component is methane, and in LPG the main component is butane. Yes. Next, this is the concept what we have learnt in today's class, that is effects of burning fuels. Already we have discussed, just once go through that.